Yeah. Okay, hello everyone. I'm Wrobel, and I'm here to tell you about a personal project of mine. And I would call even this is an introduction to how you can utilize VR and machine learning for training robots. So before I start, a couple of words about me. So I'm a software engineer, and I've worked as such for a couple of years. And then I turned to product management. And for the past year, I worked in VR, AR space. In my free time, I'm a sport climber. I hope you've seen the climbing wall experience and in the expo booth. So it all started 6 months ago when I worked at Polydia, and we were tasked with creating a VR gaming experience for the conference. And then we thought that it would be really great to enhance this with a physical robot around. We called him Marvin. So the game was about, the user was an operator of the conveyor belt in the factory. And using VR controls, he had to sort stuff. And whenever the user put a special block in the proper place, then the robot in the real world recreated more or less the same movement. So you can see the video from the gameplay, and you can see our robot working relentlessly on putting those blocks from one place to the other. So this is quite great, but programming robots is quite easy for simple and repeatable tasks, like moving blocks from one place to the other. And for instance, with universal robots, that's the one you have seen in the video, you can program it using a built-in tablet solution, or you can even use your own hands to tell it exact movements and record it. And it will repeat it for the years, like the same path. But what if we wanted for a robot, like a human-shaped robot, to do a backflip? And you might have already seen the video from Boston Dynamics, where they taught a robot to run a parkour course, and at some point, yeah, it will even do a backflip. When I saw that, it was really mind-blowing. But then I thought, okay, how a small one can do something like this? Because it's quite challenging task to train a robot in dynamically changing environments. And we don't see that, but those research teams, they fail numerous of times when they try to teach a robot. And it's really expensive. Those toys are millions of dollars investments. So for now, only big companies were able to advance machine learning and robotics. But there is a way. So now machine learning algorithms are enclosed in libraries which developers can use. And what you can do with the physical world, you can recreate the same environment in a digital world. So for instance, you can recreate a factory inside a Unity. And freshly released toolkit, machine learning agent toolkit from Unity, allows you to incorporate reinforcement learning algorithms into your projects. And reinforcement learning is this really cool part of machine learning where you teach the certain behavior by rewarding the correct actions. So at the beginning, you have an agent, AI, robot, or whatever, and he doesn't know anything at all. He will do a random actions. But whenever he performs an action that you want it to make, it will get a reward. So assuming we have a challenge 1, and we want to teach a robot to walk. So we need to reward it. It will not know what walking is about. It will not understand that it has so many limbs and how he should adjust the angles of those limbs. And we need to reward it for something. So we will reward it whenever it will keep head as high as possible and move forward. So at the beginning, once you run the program, you will see something like this, a random dancing movement of a ragdoll. But after 5 hours of training, with reinforcement learning, you will see something like this. And you can see that the robot found a way to to progress forward and keep head as high as possible by jumping. Okay, so this is more of a simple game that you have seen. So what if you want to teach a real collaborative robot to balance a ping pong ball on a plate? So we can recreate, we need to tell it what he will be rewarded for. And the robot will be rewarded if he catches a ball on the plate and keep it there as long as possible. And we recreated the environment in Unity. And those robots that you have seen at the beginning, those are the physical, like digital representation one-to-one of the physical robots. And at the beginning, they will behave randomly. They will try to catch a ball. They don't know what catching a ball means. But after 5 minutes of training, you will see that they already experimenting with smaller movements. They are trying to catch a ball where it falls. And after 20 minutes of training, our robots, our farm of robots, will find a way to balance a ball. They will not be perfect. They will still miss a ball sometimes. But remember, they didn't know what balancing a ball means at all. So it does a pretty good job just after 20 minutes of training. Okay, so what is needed? Still, we have a reward function, and we need to program it. So we still need programmers to do that. We need a machine learning expertise because we need to understand why, for instance, our algorithm doesn't work, and maybe we need to change a reward function. And 20 minutes, 5 hours, it's quite a long time. So is there a better way? And obviously, yes. So you can use VR controls for imitation learning. And imitation learning is part of reinforcement learning methods. And in this particular case, you don't have to define specifically what will be the reward function, but you can tell the robot to try to mimic the behavior of a human as exact as possible. So we recreated an environment where a human can control a robot in virtual environment and adjust its position and rotation. Using this environment, after just 2 minutes of training, we will see that the robot, like a user controls the teacher robot on the left and controls the plate and the ball, balancing a ball on the plate. And on the right, there is a machine learning robot, a student, and we will see that at some point, it will start to behave in an expected manner. Not 20 minutes by 2 minutes, and it already found a way to balance a ball. Later on, we can just leave it and try to be at this task as good as possible. It will find a way eventually, but at the beginning, the human can help. And what are the advantages here? We don't have to have a programming skills to do that, because we will just basically tell a skilled worker that he should perform his tasks as usual, and the machine learning will try to incorporate its behavior. There is not much machine learning expertise needed anymore, because if we enclose it in a toolbox, then basically we can just use our experts to do the training. And there is a shorter learning cycle, because you can much easily tell the robot what the proper behavior is. So to sum it all up, I think that in the future, collaborative robots will be as popular as robotic vacuum cleaners are today, which means either you or your friends will have one. So we need tools to train those robots. We need a toolbox that anyone can use and basically use motion capture data from human movements to train robots. And as you can see, it's not anymore about one technology, like machine learning, AR, VR, or robotics. It's rather about combining them together and utilizing them to help decision makers solve high-level problems. Balancing a ball maybe is not a high-level problem, but there are some. And from consumer perspective, I think it would be nice at some point to have robot prepare me a perfect pancake. So we need to tell robots how to flip a pancake. Obviously, if you know yourself how to flip a pancake. So if you are interested in either of those topics, shoot me an email at chris@vRational.com. That's all for today. Thank you all for listening. If you want to talk to me, I will be here around for some time. Thank you.